AP Calculus, section 5.4, page 4. We need to consider discontinuous functions and area. The type of discontinuity determines the effect. So let's look at holes in a graph versus a vertical asymptote. And if we look at trying to find the area under this curve from some spot A up to some B, and we have this hole right here. When we shade this in, there's a strip that's blank in there. And while we have to make that strip wide enough so that we can see it, really that hole has no width. That hole right here has no width. So this strip of empty space in here has no width, and the discontinuity has no effect on the amount of area. And this is a removable discontinuity. Remember that from first semester? All right, let's look at this one over here, which has an infinite discontinuity. And let's look at finding the area from some A right up to B, which is that vertical asymptote. And when we shade this in, we notice that we can keep shading in here going up. This function is getting closer and closer and closer to that vertical asymptote, but it never reaches it. And we can always, no matter where we stop before, we can always measure a distance between that function and that vertical asymptote. So the amount of area in here is not finite. So infinite discontinuities do affect the amount of area in here. Okay, this last little bit down here is to just refresh your memory from first semester in terms of a function and its derivative. So if we have some power function, x to the n, that derivative, we pull that n down in front, so nx to the n minus 1. The trig functions, the derivative of sine x, cosine x. The derivative of cosine x, negative sine x. The derivative of tangent x is secant squared x. Now notice, I am just writing these as cosine x, whereas first semester you probably memorized them as the derivative of sine u is cosine u times the derivative of the u. Well, I'm just handling this x here, not some other u function in there. So there is no times the derivative of the u here. The derivative of secant is secant x tangent x. Cosecant and the derivative of cotangent. Hopefully you remember these. If not, you need to commit them back to your memory. There's the trigs. Let's take a look at the inverse trigs. The derivative of inverse sine was 1 over the square root of 1 minus x squared. Again, you probably memorized that as 1 over 1 minus u squared, but then times the derivative of the u. Well, there is no u here, or you can think about it as times the derivative of this x, which is 1. The derivative of inverse secant is 1 over the absolute value of x, square root of x squared minus 1, and the derivative of inverse tangent is 1 over 1 plus x squared. All right, now, remember the original trig functions. The c functions, the cosine, the cosecant, and the cotangent were the ones that were negatives. And on the inverse trigs, same thing. The derivative of inverse cosine was negative 1 over this. The derivative of inverse cosecant, just negative. Derivative of inverse tangent, inverse cotangent, negative of this. So since those three are exactly the opposites of those, I did not write them down. And the last family of functions that we talked about were the exponentials and the logs. The derivative of an e to the x is just e to the x. The derivative of a natural log x, 1 over x. The derivative of a to the x is a to the x times ln a. And the derivative of log base a of x is 1 over x times the natural log of a. If you have forgotten these, let me put it back up here so you can catch that last one. If you have forgotten these, you need to recommit these to your memory. Because first semester we started here and went this direction. Second semester we're going to be starting over here and going backwards to this direction. So it's important that you have them all memorized.